So let us now discuss problem number 2. Design a reinforced concrete slab, one-way slab, which is integrally with its supports and consists of three equal spans with a clear span of 3.5 meter. So meron tayong tatlong slab dito. So yung clear span niya is 3.5, 3.5 at saka 3.5. Tapos yung longer span niya, we have 8 meter. So mapapansin natin dito, so meron siyang katuloy dito na span. And with the same end dito sa kabila din, meron din siyang katuloy, denoted by this symbol. The slabs are subjected to a live load of 5 kilopascal and a dead load of 2 kilopascal. Use 12 mm diameters main bar and 10 mm diameter for temperature bars. Apply ACI moment coefficient method and use NSCP 2015. Assume multiples of 25 mm for the minimum thickness of slab. So in computing for the minimum thickness, multiples of 25 tayo. The value of your F prime C, that is 27.6. Your Fy, that is 345 megapascal. And your steel covering, that is equal to 25 mm. So first of all, let us calculate for the value of your floor pressure. So hanapin natin yung floor pressure natin. O yung superimposed dead load natin. So since we are using NSCP 2015, that is 1.2 dead load plus 1.6 live load. So for this one, we have a value of 1.2 floor live load in kPa. Yung dead load natin, that is 2 kPa, plus yung live load natin, that is 5 kPa. So you will have a value which is equal to 10.4 kPa. So after computing for the value of your superimposed floor load, next let us calculate for the value of the thickness of your slab. So sir, paano po natin kukunin yung thickness ng slab natin? So we will going to use yung mga formulas natin. So for this one, since titingnan natin dito, so continuous siya dun sa kabila, and the other one continuous din siya. So both ends are continuous. So yung formula natin dyan in computing for the thickness, that is equal to L over 28. Kaso nga lang, yung Fy natin, that is not 420 megapascal. So kapag hindi 420 yung Fy natin, so maglalagay tayo dito ng pagmumultiply natin dun sa L over 28. So that is 0.4 over Fy plus Fy over 700. So yung L natin dito na gagamitin, that is the clear span nung shorter span natin, which is equal to 3,500 over 28 multiplied by, so 0.4, plus yung Fy natin, which is equal to 345 over 700. So the value of your H minimum or the value of your thickness is now equal to 111.61 mm. Kaso nga lang sabi dito, your H minimum must be multiples of 25. Since dimension tayo dito, we will going to round up our dimension. So round up natin yan, that will be 125 mm. So that will be the thickness of your slab. So after computing for the value of your thickness, let us now calculate for the value of your weight of your slab. So hanapin natin yung weight ng slab natin. So that is equal to unit weight of concrete multiplied by the thickness. So for this one, sabihin natin na yung unit weight ng concrete natin, that is 24 kilonewton per cubic meter multiplied by the value of the thickness, which is equal to 0.125 meter, or etong 125 mm natin. So you will have a value in kPa which is equal to 3 kilopascal. And after natin ma-compute yan, siyempre, so nagkaroon tayo ng weight ng slab natin, ilalagay natin yan dun sa total floor load natin. So for this one, kunin muna natin yung value para makuha natin, kunin natin yung MU max natin at saka yung VU natin. So for this one, with weight ng slab mismo included, with weight slab included. So para ma-include natin yan, so yung natin dito, yung floor load natin, yung capital double U sub U. So that is 10.4. Yung total natin, that is equal to 10.4 kanina. Plus yung weight ng slab natin, that is 3 kPa. Kaso nga lang, dead load dyan. So, gagawin natin plus 1.2 multiplied by 3. So, you will have a total of 14 kPa. After natin ma-compute yan, we will now calculate for the value of your MU max at saka yung value ng VU max natin, including the weight of your slab. So, for this one, para maging kilonewton to, we will going to consider a 1 meter strip. So, meron tayong kPa, that is kilonewton per meter squared. Considering 1 meter strip. So, sa mga slabs natin, di ba, we are considering 1 meter strip. So, dito na-consider tayo ng 1 meter strip. So, mag-consider tayo ng 1 meter strip is equal to 14 kilonewton per meter. After that, let us calculate for the value of your MU max. So, unahin muna natin yung sa support natin. So, at support, kung titingnan natin dito, meron tayong dalawang value ng MU max natin. Kasi meron tayo dito sa support at saka yung sa midspan natin. So, ang gagamitin natin yung ACI moment coefficient as indicated sa problem natin. So, gamitin natin yung shortcut in computing for the value of your MU max negative and MU max positive. So, yung natin dito, kung titingnan natin yan, so, nadirito yung natin, nadirito yung positive sa gitna. Nasa gitna yung mga positive natin. Positive moment, positive, positive. Tapos, nasa support naman yung mga negative moment natin. So, kung babalikan natin yung ACI moment coefficient, kapag positive moment sa midspan, sa mga interior spans natin, that is always 1 over 16. Positive 1 over 16, positive 1 over 16, positive 1 over 16. Kapag naman sa mga natin, sa mga supports natin dito, so that will be, so nangyari kasi dito, ito yung mga natin, interior. Ito yung mga interior supports natin. Kasi di natin naka-continuous sa kabila, continuous din sa kabila. So meaning to say, etong mga span natin dito, etong tatlong span na to, interior span yan. So meaning to say, etong mga to, we can assume na mga interior support yan. So sa codes natin sa ACI, so at support daw ng mga natin, interior spans o yung mga interior supports natin, yung value other than, yung value is 1 over negative 1 over 11. Negative 1 over 11. Negative 1 over 11. Negative 1 over 11. So, after natin ma-compute yung mga values ng coefficient natin, let us now solve for the value of your MU max. So, unahin muna natin yung MU max natin found at the support. So, the formula will be MU max at support, that is equal to, gagamitin natin yung formula natin, which is equal to negative, kasi nasa support tayo. So, you will have WU L squared over 11. So, yung WU natin, that is equal to 14. Yung clear span natin, that is 3.5. Parehas lang naman. 3.5 plus 3.5 over 2, that is equal to 3.5 over 11 is equals to 15.59 kilonewton meter. Next naman, let us calculate for the value of your mu max at mid-span. Dun sa gitna naman. So that is equal to mu max. So that is WU L sub n squared over 16. So yung W natin dito, that is equal to 14 multiplied by 3.5 squared over 16. So you will have a value of your mu max which is equal to 10.719 kilonewton meter. After that, let us calculate for the value of your VU max. So yung VU max natin dito, that is only 1.0 WL over 2. Kasi nangyari dito is wala naman tayo dito na first interior support. Diba? Sa first interior support, yung exterior face niya, that is 1.15. Kaso, etong mga supports natin, nasa loob na, nakapagitna, or mga interior supports na sila. Hindi sila first interior support. So, meaning to say, 1.0 lahat yung nandirito sa mga natin. Sa mga face ng mga supports natin. Kaya 1.0 yan. So, you have WU na 14 multiplied by 3.5 over 2. And siyempre, ginamit natin yung 3.5 dito for the clear span kasi nga kahit na i-average mo yung mga adjacent spans, 3.5 din yung sagot kasi parehas lang naman yung dimension nila. So you have 24.5 kilonewton meter. Next, after we compute for the value of your mu max and the value of your VU max, let us now calculate the value of your reinforcement sa main bars. Let's compute for the value of your AS and the value of your spacing. Sir, paano po natin gagawin yan? So, kunin muna natin yung value ng D natin. So, that will be, so yung thickness natin. So, ito-draw natin yan. So, this will be like this. So, meron tayo dito mga main bars. Tapos, nandito yung mga temperature bars natin. So, ito yung kinonsider nating 1 meter strip. 1,000 mm. Tapos, from the center of your main bars hanggang dun sa outermost fiber, that is designated by D. So, paano natin i-compute yung value ng effective depth natin? So, yung thickness natin, which is yung na-compute natin na H minimum, so that will be 125 minus, so meron tayong 125 minus yung steel cover natin. So, dito sabi dito yung steel cover natin is 25 mm. Or from the center of your reinforcement sa main bars hanggang dun sa outermost fiber, that is 25. So, minus lang natin yung thickness natin by 25. We can now calculate for the value of your effective depth, which is equal to 100 mm. So, after nating ma-compute yung value ng effective depth natin, we can now use yung formulas natin sa pwede na natin gamitin yung principle natin, di ba? Yung mu max natin, which is nakuha natin sa mga loads natin. E, dapat mas less than or equal yan to the value of your mu capacity. Wherein yung mu capacity natin, makukuha natin yan by means of using yung mga formulas natin sa RCD. Wherein yung mu capacity, that is equal to reduction factor, nominal resistance, BD squared. So, meron tayong dalawa. Yung at support muna. So, at support. Kunin muna natin at support. So, you will have mu natin. What is the value of your mu? At support, that is 15.59. So, we have 15.59 kilonewton meter to Newton mm. So, times 10 raised to 6 Newton mm equals reduction factor 0.19. Tapos, rho Fy. Wow. So, what will be the value of your Fy? That is equal to 345. Rho Fy multiplied by BD squared. The value of your B, that is 1,000. Yung D natin, 100. Multiplied by 1 minus rho Fy. Yung Fy natin, that is 345 over 1.7 F prime C. What is the value of your F prime C? That is equal to 27.6 by ship. So we can now calculate for the value of your rho, which is equal to 0.00522. So that will be the value of your still ratio at support. After we compute for the value of your still ratio, let us now calculate for the value of your rho minimum muna natin. So tingnan natin kung mag-greater than ba yan. Sabihin natin this is your rho minimum. So that is equal to 1.4 over Fy. So yung Fy natin, that is 345. So that is equal to 0.00406. Yung isa namang formula natin for rho minimum, that is equal to square root of F prime C. So meron tayong square root of 27.6 over 4 multiplied by Fy. So the value of your rho minimum here is 0.00381. So i-adapt natin yung higher value for rho minimum, which is eto yung gagamitin natin. Pagko-compare natin siya to the value of your rho actual. So this is greater than rho minimum. So eto yung gagamitin natin. So that is okay. So after natin ma-compute yan, we're going to calculate for the value of your area of your cell reinforcement. So that will be rho BD. Rho BD. Yung rho natin, that is 0.00522. Yung B natin, that is equal to 1,000 mm. And yung D natin, that is 100 mm. So you will have a total of area which is 522 mm squared. So let us calculate for the value of your spacing. So ratio and proportion lang tayo. AS over 1,000 is equals to yung area ng isang bakal over yung spacing. So we will have yung AS natin na 522 over 1,000 equals yung area ng isang bakal. Gagamitin natin for main bars, that is 12 mm over spacing. So the value of your spacing is now equal to 216.66. Kaso nga lang, that must be divisible by 10. So round down tayo kapag spacing. So you will have a value of 210 mm. And after natin makuha yung actual spacing, co-compare natin yan to the value of your S max, which is equal to 3H. So 3 multiplied by 125. So you will have 375 or yung 450 mm. So etong tatlong to, 210, 375, 450, gagamitin natin dyan yung smallest. So gagamitin natin S is equals to 210 mm, 12 mm diameters on centers. So after natin ma-compute yung value nung sa support natin, we will now calculate for the value naman ng spacing natin dun sa midspan naman. So let us now calculate naman yung sa midspan naman natin. So let's calculate at midspan. So same procedure lang tayo dito, no? So gagawin lang natin dito is we will just gagamitin lang natin yung MU max. That must be greater than or equal to the value of your MU capacity. So gagamitin natin yung mga formulas natin sa flexural in computing for the value of your rho. Okay? So for this one, yung MU max natin, that is equal to 10.719 times 10 raised to 6 para maging Newton mm is equal to, so meron tayo dito rho Rn BD squared. That is our formula. So for this one, yung reduction factor natin, that is 0.9 multiplied by yung rho, yung Fy natin, that is equal to 345, yung B natin, that is 1,000 Yung D natin, that is 100 multiplied by 1 minus rho Fy, that is 345, over 1.7, yung F prime C natin, which is equal to 27.6. So the value of your rho by shift solve is now equal to 0.00354. Wherein that is less than the rho minimum natin. So meaning to say, okay, at yung gagamitin nating formula. So, hindi pala, kabaligtaran pala, no? Yung raw minimum natin, so, di ba yung raw minimum natin, that is equal to, based dun sa nakaraang solution natin, that is equal to 0.00406. So, yung raw actual natin, nag-less than siya to the value of your raw minimum. So, meaning to say, yung gagamitin natin dito is, we're going to use yung raw minimum natin. Kasi ito yung minimum value eh. Tapos yung nakuha natin is less than the minimum value. So we're going to refer to the minimum value. So the value of your ES is now equal to rho BD. Kaso nga lang yung rho natin, gagamitin natin is the minimum value multiplied by yung B natin na 1,000 multiplied by D na 100. So the value of your AS is now equal to 406 mm squared. So after nating makompute yung value ng area of steel reinforcement natin, we're going to compute for the value of the spacing of your reinforcement dun sa ano natin, dun sa midspan natin. So yung formula natin dyan will be ratio and proportion lang tayo dito. So that will be AS over 1,000 is equals to yung area ng isang bakal over yung spacing. So yung AS natin na 406 over 1,000 is equals to area ng isang bakal, that is 5 over 4 multiplied by 12 squared over yung spacing natin. So yung na-compute natin spacing dyan is now equal to 278.56. Kaso nga lang divisible by, then dapat tayo, so this will be 270 mm. So after that, i-compare natin yan to the value of your S max, which is equal to 375 mm, or yung 3H, yung na-compute natin kanina, or 415. Therefore, gamitin natin is yung smallest value among the three, 270, 375, 450. So yung lowest natin dyan is 270 mm. So, meron tayo ditong 12 mm diameters on center at midspan. So, yung kanina at support naman yon. So, after that, nakuha natin yung mga actual spacing natin. Nakuha natin yung mga actual spacing natin sa support at saka sa midspan. So, we will now check yung check yung flexure naman. So, sir, paano po natin i-check yung flexure? So, in computing para ma-check natin yan sa flexure, dapat yung MU capacity natin, that must be greater than or equal to the value ng MU max natin. By principle, para ma-consider natin safe yan. So, first, unahin muna natin yung at support. So, at support, paano natin makukuha yung MU capacity niyan, sir? So, hahanapin natin yung value ng MU capacity natin dun sa support natin. So, dun muna tayo dun sa support natin. So, kung maaalala natin yung spacing natin for the supports, that is equal to 210 mm on centers, diba? So, support. Spacing that is 210 mm on centers. So, dito naman, gagawin natin is magbabackstab tayo. Kasi ito na yung gagamitin natin. So, di ba sa mga previous calculations natin sa pang-compute ng spacing, nag-round down tayo. So, ngayon, kung gagamitin natin daw yung 270 or yung 210 dun sa support, what will be the value ng MU capacity natin doon? O yung actual na kakayanin nung nung slab natin na dalhin. So, for this one, backstab lang tayo. So, gagamitin lang natin etong ratio and proportion natin na AS over 1,000 is equals to yung area ng isang bakal natin, gagamitin natin, that is 12 mm squared. Over yung spacing natin kanina, hindi given to. Ito yung kino-compute, kaso nga lang nga right now, kukompute na natin yung value ng AS natin. So what will be the value of your AS? So you have a value which is equal to 538.559 mm squared. So after nating ma-compute yan, let us now solve naman yung rho naman natin. So that will be AS is equals to rho BD. So that will be 538.559 is equals to rho. Yung B natin, that is 1,000. Yung D natin, that is 100. So the value of your rho, that is equal to, so meron tayo ditong 0.00539. Okay. So after natin ma-compute yung value ng rho, kunin na natin yung value ng MU capacity natin, that is reduction factor, rho Fy, BD squared multiplied by 1 minus rho Fy over 1.7 F prime C. So, MU capacity at support, that is equal to 0.90. Yung rho natin na 0.00539 multiplied by yung Fy natin na 345 multiplied by 1,000 multiplied by 100 multiplied by 1 minus yung rho natin multiplied by 345 over 1.7 na 27.6. So you will have a value of your MU capacity which is equal to, wait lang ha, compute natin. So that is equal to 16. So, eto, meron lang mali sa formula natin. Hindi natin nalagay yung squared sa D. Squared. Okay. Naka-squared dyan. So, that is equal to 16.06 kilonewton meter. So, times 10 raised to 6 yan. So, alisin natin yung times 10 raised to 6 para maging kilonewton meter yan. Which is, etong nakuha natin na MU capacity that is greater than to the value ng MU max natin na dadalhin nung slab natin which is equal to 15.59 kilonewton meter. Therefore, safe tayo at support. So, tingnan naman natin kung safe ba tayo at midspan naman. So, at midspan. So, at midspan, ganun din naman yung magiging natin, response natin. So, meron tayo ditong spacing which is equal to 270. So, magbaback solve lang tayo para makuha natin yung actual steel reinforcement. So, yung area ng isang bakal, that is pi over 4 multiplied by 12 squared over 217. So, the value ng AS natin, that is equal to so, meron tayong value dito which is equal to 418.879 mm squared. So, that is equal to rho BD. So, this will be equal to, so, meron tayong 418.879 is equals to rho. Yung B natin, that is 1,000. Yung D natin, that is 100. So, the value of your rho will now equal